and we have already covered physics, semiconductor, part 1, 2, 3 and 4. Now, today we are going to deal with part 5. In this, we have to discuss something about oscillator. So now we will see what is oscillator. So this type of oscillators are available in market which are used to generate a oscillating frequency. What is the use of oscillator? To generate oscillating frequency. Now you may have a question, sir, for what reason oscillating frequency is needed, right? So we will see that one by one. So if we will connect this oscillator to CRO, CRO is cathode ray oscilloscope. This is cathode ray oscilloscope, which is used to represent the frequency, right? So if we will connect this oscillator to this oscilloscope, it will give such type of oscillation. It will give such type of oscillations, right? Now, how it actually works? So technically, oscillator has first amplifier, second feedback network. What it does, it receives the power supply plus minus, and whatever frequency it will amplify, it will give it to output, and same frequency will be given back with the help of feedback network. With the help of feedback network. So whatever we have amplified, again it is going, again it is amplifying, again it is going back, again it is amplifying. It means it is busy in oscillating the frequency again. But looking at its construction, it has metal plates, right? Just before we have seen a metal box as an oscillator, right? It is very small and it has two metal plates. With these two metal plates, we have applied positive and negative of the signal to this metal plate. And then Himanshu, what it will do? It will try to oscillate, or the electrons will try to jump between these two plates, and thus it generates oscillating signal, right? Yes. Now, as I asked, for what purpose this oscillating frequency is used? So we people are using computers, right? On that motherboard is there. On that motherboard we have microprocessor and microcontroller, or we can call it as a simple processor, right? We usually talk about i3, i4, i5 processor, p4 processor. So all these processors need a triggering pulse. What it need? Triggering pulse. Now sir, what is triggering pulse? Right? It is just a ignition to run the further process. और इन अ सिंपल लैंग्वेज, किसी भी फ्रीक्वेंसी को अगर मुझे प्रोसेस करना है तो उसके लिए आई नीड अ रेफरेंस सिग्नल. व्हाट आई नीड? रेफरेंस सिग्नल. अगर रेफरेंस सिग्नल नहीं है, सो वी कैन नॉट डील और वी कैन नॉट प्रोसेस विद द फ्रीक्वेंसी. और सिंपल अगर मैं बताऊं, वी आर यूजिंग वॉचेस, राइट? क्वार्ट्ज watches. Every watch in the world run with the reference of 1 second. Yes. Few of them might run on milliseconds even. Sports watches, digital watches. That is fine. But everywhere in the world, the reference is 1 second. If we do not have reference, then can we able to match our watches? No, not at all. So there must be a reference. So for every microprocessor, microcontroller, we need a reference signal or reference frequency, and that is nothing but oscillating frequency. Clear? Yes. So here at 0 degree and 180 degree, here if you are getting 0, it will be amplified again and will get 180 degree phase shift in that. Again that 180 degree will be given back, again it will go up and so on. So it will become 0 again 180. When a part of the output of amplifier is coupled to the input of amplifier, it is called feedback. It's called feedback. When the feedback sample is out of phase with input, it is called negative feedback. Means if we have given 0 degree, sir, what do you mean by 0 degree and 180 degree? Please explain. So we have given signal like this, right? 0, 180, 360, right? ऐसा signal हमने दिया. And if at the output, Mohit, if at the output if we are getting signal like this, it means it is completely opposite, shifted by 180 degree. Yes. So इसको क्या कहेंगे हम लोग? But phase क्या है? Out of phase क्या है? Out of phase. और in phase स्नेहल हम लोग कब कहते हैं in phase? अगर same frequency same phase में है, same everything, if everything is matching, then in phase, then it is called as in phase. In phase. Otherwise that is out of phase. When the feedback sample is in the phase with input is called as positive feedback. Means when it is in phase, it is positive. When it is out of phase, it is negative. For oscillator, positive feedback is required. Frequency of oscillator is F equals 1 upon 2 pi under root LC. Please note, what is the frequency? 1 upon 2 pi under root LC. Now you can ask questions, sir, what is L and C? L is inductor. L is inductor. C is capacitor. Now you may ask one question, sir, what is inductor and capacitor? Pay attention. Those who are not aware, inductor is a component, is a physical component which is used to oppose the change in flow of current. Its unit is Henry. And now what is capacitor? Two metallic plates separated with dielectric material. Dielectric to store charge in it, and its unit is farad. Fine. Now if you will focus on the definition of inductor, बाद में आप लोग लिख लेना, वीडियो में से आराम से लिख लेना, पहले कंसेप्ट को समझो, अदरवाइज लिखना और सुनना इसमें मैच हो सकता है. What is inductor? Which is used to oppose change in the flow of current. सर ये definition हमें कहीं सुना सुना लग रहा है, कहाँ सुना है हमने? Resistor. What it is? Opposition
to the flow of current.
to the
Flow of current.
flow of
Current.
Sir, then what is difference between these two? Whether resistor is equal to inductor? No, because there is a word called
Change.
See, both the definition oppose to the change in flow of
Current.
current. That is opposition to the flow of current. Sir, what is difference? Technically, what is difference? Now, this smart TV is getting current, getting voltage, which is continuous, which is not at all changing in between. But in case if it has some fluctuation, that is change in the flow of current. Current कैसे आना चाहिए था? Like this, right? But अगर उसमें all of a sudden कुछ change हो जाए, फ्लक्चुएशन आ जाए, तो उसे अपोज करने का काम कौन करता है? इंडक्टर. क्लियर है? रजिस्टर का सिंबल सबको पता है. व्हाट इज द सिंबल ऑफ रजिस्टर? लाइक दिस, राइट? इन ओम. इंडक्टर का सिंबल अगर पता नहीं होगा तो लाइक दिस इज अ कॉइल, बरोबर? एंड फॉर कैपेसिटर, राइट? Two parallel lines, right? Again we will revise all these three. Resistor, opposition to the flow of current, right? It is denoted by R, measured in ohms. Inductor, which is used to oppose change in the flow of current, right? Its unit is Henry, denoted by H, denoted by L, capital L, and the unit is Henry. So capacitor, two metallic plates. What it is? Two metallic plates separated with dielectric material, which is used to store charges. तो उसके अंदर क्या स्टोर होगा? चार्ज, Q, right? And its unit is farad. Sir, आपने ये सब क्यों बताया? Because formula of frequency of oscillator is F is equals 1 upon 2 pi under root of LC. L stands for inductor, C stands for capacitor. अब clear है?
Yes.
I hope मोहित अभी और concepts clear हो रहे हैं. पहली बार कुछ चीजें सुन रहे हैं, so it's good. So now you will understand the value of revising all these lectures again and again, because many of the time we just blindly copy the formulas. Everyone, not even Mohit, but everyone, we are what is our habit? We do not raise questions. We must raise questions if we are not understanding anything. Now, voltage gain. Already we have studied this voltage gain in the previous few episodes, but still, what is gain? Output upon input. What is gain? Output upon input. Sir, नहीं समझा. Gain. What is the literal meaning of that gain? Something which we will receive. कुछ हमें मिलना, उसको gain कहते हैं. Loss, जो loss होता है, right? So gain का अर्थ ये हुआ, आपने इनपुट दिया था 100 मार्क्स का. आपने पेपर कितने मार्क्स का लिखा? 100 मार्क्स का. उसमें से आपको 95 मिले, तो आउटपुट कितना है? 95. सो उसका गेन कितना हो? 95%. इसे को कहीं पर एफिशिएंसी भी कहा गया है. एफिशिएंसी इज आउटपुट अपॉन इनपुट. सो अब यहाँ पर हम लोग रेशियो किसका ले रहे हैं? Where AF is the voltage gain with feedback, A is voltage gain without feedback, beta is the feedback factor, and VF is feedback voltage sample. If for some frequency A beta gets equal to 1, it is actually A beta. In this formula it is like this. Because of some points or technical issues, it is shifted below, but it is A upon 1 minus A beta. So what they ask, if for some frequency A beta gets equal to 1, the system gain becomes infinite.
Infinite.
System gain क्या होगा?
Infinite.
अब पूछो कैसे?
कैसे सर?
देखो स्क्रीन को ध्यान से देखो. What they said, A beta is 1.
One.
तो फॉर्मूला क्या होगा? A upon 1 minus 1.
One.
So A upon
Zero. Infinity.
when anything upon 0, that became
Infinity.
infinity. बरोबर?
Yes.
So what they said, AF became infinity and the circuit begins to oscillate at the frequency. The condition A beta is equals 1 is called as Barkhusen's criteria for sustained oscillation. Sir, अभी ये Barkhusen's क्या है? The one who has developed this, the person Mr. Barkhusen, and with the honor of his name, we are calling it as Barkhusen's criteria of sustained oscillation. What is the Barkhusen criteria? A beta अगर 1 है तो वो infinity होगा. And AF is infinity and the circuit begins to oscillate at that frequency. That condition A beta is 1 is called Barkhusen's criteria. A beta जब 1 होता है उसको कहते हैं
Barkhusen's
criteria.
For sustained oscillation.
अब कुछ बुद्धिजीवी ये कह सकते हैं कि सर ये सारे पॉइंट्स लेसन से निकाले गए होंगे या नहीं है, राइट? बट this is very important part as far as semiconductor is concerned,
Okay.
right? This can be asked for CET, this can be asked for JEE. Now what all of application it has? They are used in radio, TV transmitter, receivers. They are used in laboratory testing equipment. Again, they are used in computers.
Yes.
If possible, I'll just show you the motherboard again with the help of to know the capacitor or the location of capacitor. Now, yes, we are talking about solar cell. Next concept is
Solar cell.
We have done with
Oscillator.
oscillator now. So now it's time to understand solar
Solar
cell.
cell.
It is a PN junction device which converts solar energy into
Electrical energy.
So we have conduction band and
Valence
valence
band.
band. Solar light will fall on the valence band, then electrons will get excited and they will jump into conduction band, right? Electrons will move up and thus energy is generated. Because from solar cell what we have to do, we have to gain the energy. Now we'll see the construction. This is what is the construction of solar cell. It has metallic contact. Solar radiation, it will receive the solar radiation from the top, right? It has anti-reflecting coating. Why? Because whatever solar light will fall inside, that can be reflected back, no?
Yes, sir.
So to avoid that reflection, we have to store maximum energy of solar rays. So to avoid of getting reflected back, so we have anti-reflection coating.
Coating.
P-type, very small P-type region is there and very large N-type region is there. Why? Because whatever solar light will fall on this, it will directly go to the N-type. It will excite all the electrons, Hitesh, and it will be pushed up in the P-type, and then they recombine and will get electricity out of it.
Yes.
This is symbol, right? So in examination, you may get question for spotting the symbols or identifying the symbol. So please try to understand the symbol and keep this in mind. What is the constructional working? Chiranjeev, a solar cell consists of silicon or gallium arsenide PN junction diode packed in a can with glass window on top. Packed in a can glass window on top. The upper layer is of P-type semiconductor. Upper layer is of
P-type semiconductor.
It is very thin. it is very thin, so that incident light photons may easily reach the PA junction. This layer is very thin. On the top face of P layer, the metal finger electrodes are prepared. Sunlight reaches the PA junction through P layer. Anti-reflecting coating of SiO2 is applied on the top surface in the gap between the metallic fingers. The active junction area is kept large to get more power. Active area क्या रखा है ये? N-type large to get more power. When photons, अब ये तो construction देखा हमने, अब working. When photons of energy HV is greater than EG, EG is energy band gap between two bands. Conduction band है valence band के बीच का gap से ज़्यादा कौन होना चाहिए? Photons का energy. Energy of photon is HV. If that energy is more, is incident on the solar cell, it provides additional electron hole pair with electrons lifted to the conduction band. Lifted to the conduction band. Valence band में थे N type, उसमें से कहाँ जाना है? Conduction band. And holes in the valence band. These electron hole pair are separated by the potential barrier across the depletion layer. The electrons on the N side move to the P side and holes in the P side move towards N side. They will be collected at the two sides of the junction. They both will be collected at the two sides. From one side negative, from one side positive, giving rise to the photovoltaic. The top metal contact P side acts as positive electrode. Top one is called as positive electrode and bottom one is called as negative electrode. When an external load resistance is connected across the electrodes, photoelectric current flows through it. So it can easily flow the photoelectric current. Uses. This is a simple calculator in which you can see these are solar cells. These are some other applications, right? Okay. Advantages of solar cell. What are the advantages of solar cell?
Saves electricity.
It stores energy and gives electricity out of it. Actually, it does not store, but based on solar cell, it converts that solar energy into electricity. So it is useful for renewable energy resources. Cost efficient तो नहीं कह सकते, but yes, it is one time investment, and once you install solar cell, it can be used for at least 25 years, right? Its age of working is up to 25 years. If in case it can be useful for more than that even. Now VI characteristics of solar cell is in fourth quadrant. The output characteristics IV curve of solar cell is plotted by the varying the load resistance RL from 0 to infinity and measuring the corresponding current. Because अब तक हमने क्या देखा था, VI characteristics either in forward bias. If it is in forward bias, then this characteristics we have seen. If it is in reverse bias, then this characteristics we have seen. So it is in first quadrant, it is in third quadrant. Now this is the only one for which we will use fourth quadrant. So keep this in mind. The short circuit condition occurs when, which condition occurs? Short circuit condition occurs when RL is 0, load resistance is 0. So V is 0, the current in this case is referred to as short circuit current, ISC. The open circuit condition occurs when RL is infinity. Load resistance infinity जब होगा, load resistance का अर्थ क्या है? सोलर सेल के बाहर एक रेजिस्टर लगा दिया हमने या फिर उसको ओपन रखा, आइदर ओपन रखा तो इंफिनिटी, शॉर्ट कर दिया तो जीरो. So infinity जब होगा then net current in this case is zero and the voltage produced is called as open circuit voltage, that is VOC, the upper one, VOC. So this is what photodiode. Next concept is photodiode. Have you people seen photodiode at your home? Yes, it is available in remote. Every remote has photodiode, right? It sends photons. Sometimes you may call it as infrared even.
Yes.
So what is the working of photodiode? Again, the light or photon energy HV must be greater than एनर्जी बैंड गैप. एनर्जी बैंड गैप से ज़्यादा ही होना चाहिए. अगर गैप से ज़्यादा नहीं है तो वो डिप्लीशन लेयर को ब्रेक नहीं कर सकता. सो फोटो करंट इज फ्लोइंग. जैसे उसके ऊपर फोटॉन्स फॉल होते हैं, लाइट फॉल होती है तो फोटो करंट फ्लो होता है. यहाँ पर अगर रिमोट का ये यहाँ पर क्या है, फोटो डायोड और फोटो रिसीवर. So photodiode is a special purpose semiconductor diode. While fabricating a transparent window is kept to access its junction to light radiation, it is always operated in reverse bias. It is always operated in reverse bias. So you can observe here the window is open, right? When light enters its depletion region and when light photons have energy HV is greater than EG, electron hole pairs are generated. अगर वो नहीं होगा तो there will not be any recombination of electrons and holes. These electrons hole flow under the influence of reverse bias and current in milliampere flows in circuit. Keep this in mind. Photodiode works in reverse bias and current range is in milliampere. This photocurrent depends upon intensity of incident radiation and is independent of reverse bias. Now application of photodiode, they are used to detect optical signal. They are used in object counters and optocouplers. They are used in remote controlled receivers, right? You heard about optocouplers. So these optocouplers are placed at metal detector door, right? Wherever we are entering from any metal detector fence, so frame, so it gives a big sound, right?
Yes.
So that is counting people also.
Okay.
It is not only checking the metal detection in our body, but it is counting number of people. How it will count? Here we have one infrared transmitter, here we have receiver. So it will count number of break in it. When we are entering from that part, अगर हम उसमें से जाते हैं तो वो count करेगा ना, 1 2 3 4 लाइक वाइज, राइट? तो क्वेश्चन ये है सर अंदर गए या बाहर आएंगे, कैसे पता चलेगा? दोनों बार कट करेगा ना, तो उसको दो रहते हैं. अगर यहाँ से ये 1 है ये 2 है, अगर 1 पहले कट हुआ और 2 बाद में कट हुआ, इट मींस पर्सन इज एंटर्ड, एंड सेकंड कट हुआ और फिर फर्स्ट कट हुआ तो एग्जिट. क्लियर है? डिफरेंस बिटवीन फोटोडायोड एंड सोलर सेल. सॉरी, photodiode is like a switch, light it up and electricity can flow through it, but the electricity is supplied external. photodiode को बाहर से सप्लाई देना पड़ता है, बट सोलर सेल को कोई सप्लाई देता है क्या? नहीं. अगर उसको पावर सप्लाई देने की जरूरत पड़ी तो उसका यूज ही नहीं है. सोलर सेल से हम लोग इलेक्ट्रिसिटी ले रहे हैं. A solar cell using essentially the same photoelectric principle is intended to generate electricity. Photodiode requires biasing while solar cell does not
Require.
biasing for breaking the PN junction. Mohit. Okay. The current in the forward bias is known to be more in milliampere than the current in the reverse bias is approximately equal to microamperes. याद रखना फॉरवर्ड बायस में जब है तब करंट ऑलमोस्ट इक्वल टू मिलीएम्पेयर, रिवर्स बायस ऑलमोस्ट इक्वल टू माइक्रोएम्पेयर. In case of n type semiconductor, let n be the majority carrier density and p be the minority carrier, that is holes. Majority carrier is electrons and minority carrier is holes, where n is greater than p. On illumination of semiconductor, there will be produced of equal number of electrons and holes. Now delta n means rate of change of electrons and delta p rate of change of holes. B increase in majority carrier density and minority carrier density due to illumination of semiconductor when both are same. Hence fractional change in the majority carrier and fractional change in minority carrier, since n is very greater than p, so delta n upon n is less than delta p by p. क्यों सर? ये तो ज्यादा होना चाहिए था, ये कम होना चाहिए था, बट ऑलरेडी इसका नंबर इज वेरी हाई, सो फ्रैक्शन वैल्यू थोड़ा कम हो जाएगा आफ्टर डिवीजन. इसका वैल्यू इज वेरी लो, सो फ्रैक्शन वैल्यू थोड़ा बड़ा हो जाएगा. The fractional change in the reverse bias current is more easily measurable than the fractional change in forward bias. Reverse bias में easily measure होता है, but forward में इतना easily measure नहीं कर सकते. It is due to this reason photodiodes are preferably used in the reverse bias condition for measuring light intensity. Right?
Yes.
So we have completed part 5th, but based on this we have to see the CET based questions. Okay. So first question, the sensitivity of photodiode depends upon. सोच समझकर पढ़कर आंसर करना है. आंसर को एक असाइनमेंट दिया जाएगा, वो 5 बार लिखना पड़ेगा, ठीक है? और हर एक करेक्ट आंसर को मिलेगा कि ना. श्रुति, क्या होगा आंसर? द सेंसिटिविटी ऑफ फोटोडायोड डिपेंड्स अपॉन light intensity and depletion region width and excess carries lifetime, excess carrier lifetime and forward bias current and light intensity. Photodiode, yes, A option A. Shruti was thinking about some other option, but so it depends upon light intensity and depletion region width. So now those who are not understanding few technical words, for them please go and watch first 4 parts and then you will understand some technical words like depletion region and other things, right? Go and watch first 4 parts. A solar cell works on the principle of photoelectricity, photographic camera, photovoltaic conversion, photosynthesis. A. Photoelectricity. Okay, we'll see. Lock करो.
Yes.
Computer G. A. Photoelectricity. Oh. उमर जी ने जल्दबाजी में दिए गए आंसर गलत है. इट वर्क्स ऑन फोटोवोल्टाइक कन्वर्जन. Because it is converting, no?
Yes.
Whatever photon it is receiving, it very first line what we have heard It converts solar energy into
Electrical energy.
A solar cell is a PN junction operating in reverse bias, unbiased condition, forward bias, in both forward and reverse bias. Yes.
Unbiased condition.
Unbiased condition. Sure.
Yes.
स्नेहल क्या लगता है तुम्हें? लॉक करो चिरंजीव. Unbiased condition. Already मैंने उस वक्त ड्रॉ करके बताया था. Forward bias is in first quadrant. Reverse bias is in third quadrant. It means it does not work even in reverse, not in forward. It means it is
Unbiased condition.
For sustained oscillation, the product of gain of amplifier and feedback factor is
Option A.
option
A.
A equal to
1.
good. Very nice. So students ने properly part देखा है and now they are answering very correct. A junction diode can be used as rectifier, condenser, off switch, and oscillator. Yes, Hitesh? B. Condenser. Okay. What is the question?
Cannot be used as.
Cannot be used as. It cannot be used as oscillator. Junction diode can be used as rest all three. Oscillator is generally nothing but an amplifier with positive feedback, negative feedback, large gain, or no feedback. Positive feedback. It's correct. Now, these are the assignment questions for today's part 5. So, all have to note down these assignment questions and solve it. Okay?
Yes, sir.
Start solving. We will meet again with the part 6. Thank you so much.